Okay, now starting the recording. All right, the
Yeah.
one that today I'm going to show you the case study that I have solved previously that I showed to you on the WhatsApp of the
Yes.
fountains, water fountains that consists of two functions, the solar radiation as well as the evaporation
Great.
from the water. All right,
Okay.
so the first, okay, can you see my screen?
Yeah.
Okay, the first step, you need to open up your SC stream, just type SCSTREAM, all right? And
Okay.
then this is the kickers. So in the kickers, the first step, you need to do the pre-processor where you create the boundary condition, you create the geometry, boundary condition, and the meshing. So click here,
Yes.
okay, and then you need to minimize, click here. All right. So after that, you need to name your project file. For example, I want to name as the fountain.
Okay.
Okay. Basically, this is the just a proof of concept only. You can integrate with the building. Okay, this is the
Okay.
fountain, and then this is the file to save. You need to save in the working directory. Choose your working directory that you want to save. Okay,
Yes.
let's say I want to save at D, and then okay, and then I want to save at training fountain fountain for training, and then if you want to create another subfolder under the same directory, you can create project folder under the above directory. You need to check here.
Okay.
So okay, so after that, just click next. All right. So let's say I want to include my fountain having the dimension 2 meter by 2 meter, right?
Right.
So my computational domain shall be more than 2 meter by 2 meter. So
Mm-hmm.
remember that previously we set by 2L, 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 and 3 to 5L for the natural
Yes.
compression. Okay, maybe the 2 meter you can set multiply with 2, which is 4 meter. Your 4 meter is your computational domain. So
Mm-hmm.
this is millimeter. Okay, you can use millimeter or meter or centimeter. For this case, I want to use the millimeter. Just click
Okay.
millimeter. I want to be 4 meter. So 4,000 millimeter.
Mm-hmm.
In Y also the same as well as the Z axis.
Mm.
Okay, you can preview, click preview. Okay, this is my computational domain. Remember the computational domain where we do the calculation inside the computational domain, our scope of CFD. So
Yes.
with the computational domain, we discretize, we cut piece by piece to form the machine. All right.
Mm-hmm.
So after that, we set the material for the computational domain as the air incompressible. Why it is air incompressible? Because the velocity of the air circulating is very slow, less than 100 meter per second.
Yes, because it's indoor, right?
Yes, it is indoor. When you set indoor, just use incompressible. And then click
Uh,
next. Okay, now you need to go through to the fluid analysis. Of course, you want to solve the flow analysis, and then the turbulent flow to be standard K epsilon. This is the general use, and this is the heat. You want to solve the heat. So the radiation maybe you won't consider, but you want to consider the solar radiation. And
yeah.
just click here, solar radiation, and then click next. Okay, for
So what
example,
do you select exactly? First, you take the flow analysis, the solve to solve it for sure,
okay,
and you define the flow type. No, it's the
the,
turbulent, right?
yes, this is turbulent,
Turbulent. Okay,
and
and
the
for the heat
turbulent
source,
model.
heat, radiation, no need.
The radiation so far not necessary because I want to show you because this don't have any radiation from the heat source. Do you have any heat source? For example, like heating parts, like
No,
cooking. Okay,
but
if you
this is my question. This consider in a patio. Patio is outside, right?
okay, this is just considered as a natural condition.
Uh,
Okay, and then
okay,
so for this case, you can consider solar radiation. It is coming from the solar. Okay,
okay.
because the heating coming from the sun normally. So the heating for this case, maybe your building, your heating coming from the sun. There is no heating process inside.
Uh-huh.
Just ideal case.
Yeah.
Okay, so the solar radiation activate and click next. So what is the internal temperature of the building? Indoor. Is it
Uh,
40 degrees Celsius, 20 degrees Celsius, 36?
it's around. How to know this one?
Okay, this one you can Google and then search your ambient temperature for your country. For example, let me search. Okay,
Okay.
the ambient temperature, you can actually, that is the data, ambient temperature uh, for United Arabic, yeah, Arabic Emirates.
Okay.
Okay, can you see? It is
Yeah.
around 35. Okay, it
Okay.
is in August and 18 degree in January. So what do you want? Okay, let's say we use 35 lah, eh? Okay,
Okay.
because we want to cool down. Definitely
Yeah.
the temperature shall be more, is higher. So let's say it is 35, and then the temperature of the building also 35. Maybe we consider as the steady state. And then the gravity 9.8 facing Z negative direction. Okay, and then check the undefined region and click next, and without no purpose, no specification, click next. This is your summary. Okay, and then finish. Okay, this is your computational domain. The blue line
Okay.
is computational domain. This is layout part. All right, the first step, you need to create the fountain. All right, so for this case,
Mhm.
I want to create my fountain 2 meter by 2 meter. Okay, just select this. This is the sketch plane. The
Yeah.
sketch plane on the ground, correct position. So just position it like this, and then press A on your keyboard. Can you see it is perfectly fits my view? Okay, if your view
Yeah.
like this, you press A, it is perfectly fit because I want to draw the cuboid that represent the base of the fountain. Okay, the fountain
Yes.
base. Okay, so what need to do? You click here by mouse. Okay, we can create the geometry by dialog. You just need to fill in the coordinate. However, I don't know the coordinate. I want to assign manually. So you need to
Yeah.
use the by mouse setting. Click by mouse setting, and then click here, cuboid, and then click somewhere else here. So this is your first geometry. So
Mhm.
click here, right click, until it appear part edit sketch. I want to edit the vertex position. Okay, I want to edit this one a little bit. Okay, maybe like this. Okay, this is actually the size. However, we know that the size is 2 meter by 2 meter, right?
Mm.
So you click here, double click. Okay, you can adjust the size X and Y to be 2 meter. 2 meter and 2 meter, and then you can preview. Okay. After that, maybe your base is as 500. Okay, and then you can apply. Okay, and click OK. Okay, this is at the center. Okay, correct. So
Mhm.
I want to create the wall. Remember, I have the wall here to guide the water from flow out. Remember? So I want
Yeah.
to, okay, like what I show to you. Hmm. Okay, can you see here? We have the wall.
Yes.
Okay, I need to create the wall so that the water won't flow out. Alright, what we need to do, okay, so I need to place my sketch plane on top of this. So I can create the wall on top of this. So how to do that? Press P button on your keyboard and press on top here. Now it changed the position. Can you see?
Mhm.
Okay, initially it is like this. When I press P button, I select on top of this, it changed the position. Okay?
Okay.
Okay, after that, adjust again the position and press A button. Okay. I want to draw the wall. Okay, how to do that? Click here. The wall is special. You need to use the sketch function. Okay, click the sketch and then just select the point. Okay, maybe the point here. 1, 2, 3, 4, and the last line you need to close the start and the end point. Can you see? It is automatically closed once we select this. Okay,
Okay.
and then go to the size or attribute and change the type to be the wall. Okay, can you see
Okay.
this? This is the solid. When you select the wall, it change. It become the wall. Okay, and then what is the wall height? Maybe 700 or 600. You can preview. Can you see?
Yes.
Okay, you can preview your wall. And then your wall thickness maybe 100. You can preview, you can see. Okay, maybe you want to have a different shape. It's okay. Just make sure it is a wall. Okay, this is your
Mhm.
wall. Okay, and then just click preview and okay. Okay, finally we managed to complete the fountain base.
Mhm.
Alright, and next I want to create the nozzle. Remember, we have the nozzle here.
Yes.
Okay, so what you need to do, create place again. Okay, position it correctly and press A button. Okay, I want to create nozzle at the center point. Okay, click here. Okay, cuboid, or you can place the cylinder as your nozzle. Click
Mhm.
cylinder and then place somewhere else here. Okay, this is your nozzle. Okay, so this is your nozzle, and then you can adjust the nozzle height. What is your nozzle height? Maybe 600. Okay, this is 600. You can preview, you can see. Okay, and then click apply. Okay, now you have complete your fountain. Okay, so after
Yeah.
you have complete your fountains, you need to do the Boolean operation in order to combine cuboid 1, extrusion, as well as the cylinder to be the one geometry. Okay, how to do that? Go to edit, go to Boolean operation. So what type of operation? I want to unite, right? I want to unite all this geometry. So go to
Yes.
unite. And then which part you want to unite? A plus B. Let's start with cuboid. Unite with extrusion. Execute it. Okay, now you can see only one geometry. So we need to unite this one with the nozzle. Okay.
Oh,
So again, go to Boolean operation. I want to unite this cylinder with the base of the fountain. Click here. And then you can name as the fountain. Okay, and then execute. complete. Can you see? It is already one geometry.
Yeah.
Alright. So you need to create, after that you need to create one point to represent the water flow at one, it is like a tube. So that it
Yes.
is the inlet of the water, like this. Can you see here? We have the point to represent the outlet of the water nozzle. So you need to place your sketch plane on top of this nozzle. Press P button and place here. Can you see it is already changed?
Yes.
And then press A button to position nicely. Zoom it, and then you can see we have the point creation. Click the point creation and click here. Okay, now we have point perfectly fit at the center of the nozzle. Okay, this is your point one. Remember, this is water generation. Let name as water generation. And then we need to assign the attribute to be the particle generation. That means the generation of the particle. The particle will represent the water. Just think the particle is the water. The water
Okay.
generation region. And then you need to, okay, this is your position. Okay. So maybe you need to adjust the height a little bit. You can adjust 1200 so that it give some space. Click apply and okay, maybe 100. Okay, 50. Alright, apply and okay. So this is complete your model. Alright. The
Okay.
next you need to create the water. Okay, that is why you mentioned that previously you have 3 gallons of water to evaporate, right? In the WhatsApp. So you can create the water volume inside this.
Okay.
Okay. So how to create the water? Okay, again, you need to change the position of your sketch on top of this uh, base, right? You can hide this found. You can go here, press P button and click here. And you see it's already changed the layout, the sketch plane. Okay, I want to start create the water from this base to the top. Okay, press P button. Okay, and then I want to use the sketch function. Okay, maybe I want to use the by mouse function and click cuboid and place anywhere here. And this is my cuboid. You can see cuboid too. Just right click, find edit sketch and place it somewhere else here.
Yeah. It's difficult, right?
Okay. Pardon?
It's little difficult.
Okay, it's
I.
okay. The first time it is quite difficult. Every software will be the same thing.
Yeah.
The first try it might be difficult. Later on, if you think it is difficult, it's okay. You can create using your software, and then import the geometry. What you can do,
Oh,
assign the boundary condition. Very simple. Actually, I'm an expert using other CAD tool. You know, Katia,
no. Katia?
AutoCAD.
AutoCAD, I know.
Yes, you can create using AutoCAD, and then you can create exactly what you need to do in the SC stream, import your geometry, and then assign the boundary condition, and then
Yeah.
do the meshing. Simple. This is just a creation lah. Okay, you can
Okay.
do using other software also.
Okay.
Okay, so this is the alright. This is cuboid. Okay, we're having the water. Okay, I want to have a certain height of the water. 500. I can preview. Okay, this is my water. Click apply. okay, and then I want to do the Boolean operation to cut the water section out of this fountain. So
Okay.
click edit, do the Boolean operation. Okay, I want to cut the void to. Okay, must make sure the operation is subtract. Okay, I want to subtract A minus fountain and execute and make sure I keep the fountain. Otherwise, my fountain will be deleted. Okay, keep my fountain and execute it. Now we have the water. Can you see the red color?
Yes.
The red line, it is actually the medium of water. Before this, it is intersect with the fountain. So we do the Boolean operation to have this geometry. So you can rename here as the water.
Okay.
Okay. And then after that, you need to assign this water as the fluid. So how to do that? Now this is obstacle. It is out of computational domain or it is not considered for calculation. So you go to parts, right click, create group. If you create the group, you can assign the water. So go here, water, and drag drop at the group one. Can you see at group one have the water property? Okay, double click the group and change the attribute to be fluid. Can you see we have the fluid? And then configure it to be the liquid, water, and set it. Okay, what is the initial temperature of the water? Maybe 20?
Yeah.
Okay, and then 20 degrees Celsius. Click apply and okay. Now you can see group 1 change to become the water liquid.
Yes.
You can see the symbol. Okay, now you have complete your geometry or otherwise you can use your AutoCAD. Okay,
Yeah.
so after that, go to boundary condition. Go to the condition setting. You need to assign all the boundary condition. Okay.
Yes.
Okay. So wait, yeah. Let me check this one. Fountain. Okay. So condition setting. Okay. First, we solve one by one. First, we need to solve analysis type. This is incompressible. It is turbulent flow, and we consider the heat. We consider the solar radiation. We consider the particle. Remember, we need to consider the water flow as the particle. And then we
Yes.
need to consider the humidity because of humidity, we have the dew condensation, we have evaporation. So consider humidity, check the humidity, and I want to be the transient analysis. Remember transient analysis for the time history. That is why you can see I play with the time from 0 second until 60 seconds. You can see the change of temperature in the inside the room, right? Okay.
Okay.
This is the transient analysis. Everything is perfect. Go to basic setting. And this is okay, pointing to the Z negative direction, my gravity. Check my direction. Okay. Okay, it's okay. And then my ambient temperature 35. Okay, my fluid region. Okay, this is okay. My domain is the air and this is the water. Can you see? Group 1, you can see the red color. It is actually the water. Okay, now go to the flow. Of course, I want to solve in X, Y, and Z direction. Okay, and the heat is degree Celsius. Okay, and then check the humidity. Okay, the humidity that we're gonna use is relative humidity. Okay, I want to consider evaporation. Otherwise, the water won't evaporate. Okay, so consider evaporation and you need to consider latent heat for dew condensation and evaporation. If you do not know here, click here. Now give you the latent heat is analyzing dew condensation or evaporation is treated as follow. Okay, you can see all the detail lah. Alright. The next is apply 100% relative as the upper limit and default 0.76. This is fixed. Okay, and then this is nothing. The humidity is okay and go to particle. Remember the particle is the water generation, right? Are you there? Hello? Are you able to hear me? Hello? Are you
Yes.
are you there?
Yes. I'm with
Okay.
you.
Okay. So, uh, you go to uh, alright. So remember that your particle is represent of the water. So you need to know the number of particle. That means the droplet of the water from the fountain. Okay. For example, I want to make it one million. Okay,
Okay.
million of droplets. Okay, you can assign 1 million or 999 infinity also can be done. Okay, the type of your particle, of course, water having the mass, right? So assign as the mass particle. After you assign as the mass particle, click here, water generation. Since we create the point, remember? We create the point. This is our point.
Okay.
Okay, can you see? This is our point. We name our point as water generation. So
Yes.
it is appear here. This is water generation at 111, okay, XYZ, and then click spray. I want to make it as a spray. Okay, so click
Okay.
spray, and then you can see the water fountain having the angle of spray.
Yeah.
Actually, you can play around the angle of spray. What would be the best optimum of the cooling system? So go to here, and then you need to specify by cycle. That means the water droplet as the particle produce every cycle. So specify by cycle and start the cycle one, and then the interval of two. Every two cycle, the water will produce. Okay, and then I need to assign the particle as the water. Go to the particle configure, and then see we don't have any water here. We need to create one for water. Go edit mode, click edit mode, and right click here, add material. Okay, my new material is water. Name as water. The density of water is
Um, I forget. Wait.
one
Density.
1,000.
Okay.
Okay, density of water is
Yes.
1,000. And the droplet of the water, let's say we make it constant, 0.1
Okay.
millimeter. And the coefficient of restitution. Do you know what is a restitution?
No.
Coefficient. Okay, that means the coefficient of restitution means the ball, upon the impact, will not bounce. It will attach to the wall. That,
Okay.
that is zero. When you have the coefficient of restitution 0.5, the ball hitting the wall will bounce half of
Yes.
the velocity.
Yeah,
So
collides. Okay.
yes, collide. After the particle collide with the ground surface, it will not bounce. We consider like this, zero restitution, no bouncing. So
Okay.
that we consider the coefficient of friction to be empirical formula. Set it and set the water again to be our property. Click set. Now our particle is water.
Okay.
And then we need to assign the mass particle per spray. Okay, this is a default value you can use. Otherwise,
Yeah.
you can increase the volume of mass, the volume flow rate coming out from the nozzle. Okay,
Okay.
0.005 kilogram per spray. One spray will produce this mass. And then I want the direction. Okay, X I don't want to adjust. Y I don't want to adjust. But Z, it is pointing upward, positive Z direction. Press you need to put 1, the positive 1 value, and the spray velocity. You can adjust. Maybe you want to create 10 meter per second, the velocity coming out from the nozzle.
Okay.
And then the diameter. This is the nozzle type is circle. We consider the nozzle type to be the circle. The diameter of the circle may be 50, and the spread angle from 0. Can you see here the spread of water from
Yes.
0 maybe 120. It is more spreading. Okay, and then
Okay.
number of parcel per spray maybe 200. The number of particle, the number of droplet per spray 200. Okay,
Okay.
and then click OK. Finally complete, and then go to the flow boundary. Okay, maybe you want to assign the x-axis, y-axis. Okay, I want to assign the wall. This one, this one, this one, this one, and this one as the open to the atmosphere, right?
Yeah.
So set the opening. Okay, set the fixed static pressure. Okay, what is the inflow temperature? 35. And then you need to set the diffusion. This is very important. Diffusion of the humidity coming out. For example, the
Okay.
diffusion of humidity is, for this case, is 10%. Relative humidity 0.1. Click OK. Now you can see you have the arrow of the flow. Can you see the arrow blue color?
Yes.
That is the interaction from internal to external. Okay, and then go to the humidity boundary. Okay, and then go to the water surface. Okay, for the okay, this is very important. This is the water, right? You need your water to be diffused out. Okay, to evaporate, right? So
Yes.
you need to create the interface of the water. Very simple. Just click here. Okay, you need to register the surface of the water and click here. Okay, this is your water surface. Okay, just register here, water surface, and then you can register as water surface and register it. Okay, after that, close it, go to the wizard again, condition setting, go to the humidity boundary, go to the water surface. Now it appear the water surface, right? So from
Yes.
here, you need to set the constant moisture flux, the exchange of the flux, the moisture from the water
Okay.
surface to the external. So set here,
Mhm.
all right, and you need to set the mass flux of the moisture. For this case, I use the default value by the software. Okay, this is the mass flux of the moisture, and use the specific value without restriction. Okay. Okay, and then um, go to the solar radiation. Okay, the type is specific. Okay, for this case, I set your country, United uh, Arab Emirates, with this, okay, with this side and this latitude. If you know the angle between Y and the end axis of the sun, you can do. Okay, for this case, just make it 0. What is your time to take the simulation?
12, 25. yeah, the simulation, I will take it on the hottest day. I
Uh-uh.
think it's August, 21st
August.
August,
August 20.
21st,
Okay, what time?
12.
12. Okay, afternoon. Okay.
Yeah,
So this is just make it 0 as your interval for calculation of the sun radiation. Okay,
okay.
when you go to this one, insolation,
Mm-hmm.
okay, you need to check here, consider reflection of direct solar radiation, consider sky
Okay,
insolation, consider the reflection of the sky solar radiation on the ground surface, and the reflectant to be zero point 0.2. If you do not know, you can click here, you can see the reflectance of the solar radiation.
yeah,
Okay, and you can set the cloudiness coefficient, weather 0.0 clear, 1.0 overcast. So maybe I want to set the weather to be 0.1 clear. Just okay, 0.1.
okay,
Okay, and then you can set the absorptance. Okay, this is the absorptant of the material from the sun radiation. Okay, this is your fountain. Okay, if you have the building, it will appear here. You can set the wall as the absorptant property differently. So
okay,
click the fountain, configure it. Okay, the absorptant to be architecture material. So this is architecture material. Just click
yes,
here, set it, finish. If you want to create the illuminance, the light, you can do as well. Click the illuminance, you can execute the analysis. So you can see the luminous efficiency of solar radiation, the shadow, the shades, you can do as well.
okay,
Okay, and then go to the analysis.
mm-hmm.
Okay, and go to the transient analysis. I want my cycle to be infinity. My last cycle to be infinity. However, I will assign the stop time. Okay, my last cycle is 99999, and I need to step my what we call my time step, fixed time step. Remember, we need to assign the fixed time step in order to make sure our current number to be ideal 1,
Okay,
0.05 second, and then go to time stop. I want to specify my time stop at 60 second, complete the analysis. Once reach the 60 second, it will stop my calculation. Okay, go to the this one, solver. Okay, nothing change. Alright, output file. Okay, go to the file specification. Okay, go to the file specification, go to option to output the file. I want to output my result every specified time interval. So every one cycle, every 1 second, I want to output my result. So select 1 second and check the initial value. Okay, and
okay,
then nothing here. Okay, I think the initial you have set. Alright. So for the initial one, this is very important. Initial condition. Okay, for the domain. Okay, the domain is actually internal air condition. You need to set the humidity. Okay, assign the initial value. You assign as humidity. What is your humidity? 0.1. Okay, 10% of the water vapor. Okay,
okay,
And then, okay, humidity, okay, simple. Okay, so finish. Okay, can we have 10-minute breaks?
Yes, sure.
Because I want to pray. It is already
Yeah,
Maghrib.
yeah, yeah. Okay, okay.
Okay, we
Yeah,
continue
bye.
10 minutes after this, yeah?
Inshallah. Okay, thank you, doctor. Bye
Okay.
bye.
Hi. Hello. Hello. Are you there?
Yes, doctor.
Okay. Shall we continue?
Yeah.
Okay. So remember, we create the geometry. You can create using your own software and import it. And what you need to do, just assign the name. Okay. So after I assign the name, register the name, I need to create the boundary condition. So how to create the boundary condition? Go to wizard, go to the condition setting. Okay.
Yeah.
So you need to go through every of these. Okay, for
Mm.
example, I go to the particle because this is the water generation, double click. Okay, maybe I want to have the water spray to be 15 meter per second. Click OK.
Yeah.
Okay, and then I set the humidity. Okay, should be no problem. Wait, yeah. Okay. Let me double check again. Okay, so everything is fine. So after we have assigned everything, all the boundary condition, what we need to do next?
Uh, you define the you start the simulation, right?
Uh,
You
I
will
I
go to the
I
you will
cannot
save it.
I cannot save it. There is one step I need to do before I can run my simulation. Remember that the solver require the solver
Three.
file and uh, the
It's
solver
required.
require two main file, the S file and the mesh file.
Yes. Okay, okay, صح.
Okay, so we
Finish.
need we need to create the mesh.
Yes.
So how to create the mesh? Go here, you can see we have the mesh icon. Click here,
Yeah.
and then I want the type to the detection of mesh to be representative. That means
Yes.
it will create the mesh by representative of the vertex only. This vertex, vertex, vertex. And
Okay.
then I need to specify the methods of grading to be rough grid and detail mesh. So here I need to specify my standard length. That means I want to cut it piece by piece. I want to make sure my standard cutting length should be 30 mm by 30 mm. So change the standard length by 30 mm.
Mm-hmm.
Common for the y and z axis, the same thing. And my treasure hole length 0.1. Okay. And everything is okay. Just go to grading. This is the
Yeah.
grading.
Okay.
Okay, and then go to meshing. Can you see this is my number of mesh
Number of
for
yeah.
around 500,000. And then click close. Okay, now see what happened to my geometry. It is meshing like this.
Okay.
Okay, can you see this is under structure mesh? It is orderly, arranged in orderly manner. This is we call a
Yeah.
structure mesh. So after that, go to the file. We need to export the file. Click export and then just save it. And then close it and save it. Okay, go to the file again. Okay, where is the file? You can go to this file. Can you see? This is the
Yeah,
this
found
is
it.
this is setup file, and this is the solver file, and this is the mesh file. In order to run the CFD, you require two files, the S file and the mesh file. So
Okay.
open back the kickers. This is your kickers. Just drag and drop the S file. Click here, drag and drop to this solver. It will launch the program. This is the program. Okay, this is waiting your command. You want to execute or not? Just click here and execute it. Are you sure? Yes. Okay, can you see it is progress rate of view factor? Why we use the view factor? Because we employ the sun radiation. The sun
Yeah.
produce the radiation, so the surface of the fountain require the view factor to capture the radiation.
Okay.
Okay. Okay, so from here you can see the number of process to processor to process my simulation. Okay, we wait for a while. Okay, at the same time, okay, wait here. Okay, luckily I have run simulation for you. We don't have to wait this one to complete. It is 1 hour job to complete. So
Oh,
it is because this require many function like particle, you have the solar radiation, you have turbulent flow. Okay,
yeah.
this is the temperature. Remember that
Okay.
this is the temperature um, domain. Okay, domain is the your computational domain. What is the
Mm-hmm.
max? What is your maximum temperature of your computational domain? You can see it is 35.
Okay.
Do we set 35 before our computational
Yes.
domain? Yes,
No,
that is
before. Yeah,
uh,
when you enter the date, you put 35, right?
yes. Okay, can you see the minimum temperature? It is 35. It is dropping in temperature. Do you know why
Okay.
the temperature drop?
Because of the water, the
Yes,
evaporative cooling.
because of the water evaporative cooling, the air temperature near or close the surface of the water drop the temperature. Can you see the temperature drop over
Yes.
the cycle? Okay.
Mm-hmm.
And next we go to the flow rate. This is nothing. This is mass flow rate, conservation of mass, and this is relative error. All right, the relative error coming from the matrix form. Since we solve the governing equation, so what is our governing equation? We have three governing equation. The first one is conservation of.
Temperature.
Okay, you
What?
remember our governing equation: conservation of mass, conservation of momentum, and conservation of energy. These
Oh,
three
yeah.
governing equation are required to be solved individually in every cell, in every mesh. So remember, you have 500,000 of mesh, right? So
Yes.
your three governing equation required to solve in 500,000 of mesh. So your governing equation require three axes: x axis, y axis, and z axis. So whenever they solve using three governing equations, the matrix will output the relative error. This is the relative error.
Okay.
Okay, this is velocity. Since we set the velocity of the water droplet, okay, you can see this is 9 maximum. Okay, this is pressure. This is temperature. Okay, after the simulation has been completed, let's see the result. Okay, this is the
Mhm.
result. Okay, can you see?
Yeah.
Okay, we have, okay, remember that we have said before, every 1 second it will output one result file. Remember, every one cycle, if every 1 second, 1 second, 2 second, 3 second. So you can see here, this one, can you see?
Yeah.
Okay, we start from here. This is our initial file until here. How many files that we have here?
Many file.
61, right?
61. Mm.
It represents actually 61 seconds. So remember, every file will output, every second will output one file. Okay.
Okay.
Now I want to view my result. Go here, launch the XC stream. Okay, this is my kickers. Okay, just go to the last file, 1201 cycle. Just select the last
Mhm.
file, drag and drop to the post processor. This is post processor, this is solver, and this is pre-processor. Just drag and drop into the post processor. Wait for a while to be opened. Okay, this is your file. Okay,
Yeah.
this is the raw, the one that I created to you just now. It is actually the adjustment. You need to play around with the particle shape. It is for the demonstration. I give you the best video lah. So how to create that? Okay, so you can see this is the sun radiation,
Yeah.
the solar radiation. Okay, this is your solar radiation. I try to measure at 2 p.m. 14 hours. Okay. Okay, you can see the pink color here. What is the pink
Yeah.
color represent?
Water.
Yes, it represent the water. Okay. So I want to make sure my pink color here represent the droplet. It is a round shape. So how to
Yes.
do that? This is my particle. Can you see? I try to hide and then click draw. It is nothing. I try to open back
Okay.
my particle. I click draw. I can see this is my particle.
Yes.
Okay. Okay. So how to change the shape of the particle instead of rectangular? Okay. We can adjust the shape. Double click the particle. So once you double click the particle, you can see the color. What do you want to display the color? Of
Blue.
course, okay, I want to display the blue. You can change the blue here. Okay, and then scroll down. Can you see it is blue?
Yes.
Okay, so minimize this. Okay, I want to make sure it is not considered as a point, considered as the circular shape or sphere. Untick the point and change the scale. Maybe 1, okay, and then scroll down. Can you see?
Yes.
Okay, this is very big size of your water.
Yeah.
Okay, you need to adjust the scale. Okay, I used previously 0.3 and click here. Okay, can you see?
Yes.
Okay, for example, I want to use this because I want to zoom out. Okay, this is your water droplet.
Yeah.
Basically, your water once entering the water font here, it will become it will diffuse into the water. This droplet. Okay,
Okay.
this is perfectly fine. Okay, this is my water droplet. Okay, adjust the position. Okay, I want this position. Okay, I want to view in the vertical plane. Can you see this is the red line? The red
Yes.
line represent the plane. I want to change the orientation of this plane. So go to the here plane, double click to the plane. You can see we have coordinate. Can you see?
Yes.
Okay. I want to have the orientation of the plane perpendicular to the Z axis. Can you see we have Z axis here?
Okay.
Perpendicular. So select Z axis and scroll down. Can you see? The
Yes.
orientation change. Alright.
Okay.
Okay. Okay. So, and then press A button on your keyboard to adjust the view perfectly. Can you see?
Yeah.
Okay. So, so, wait ya. Okay. Okay, I can hide my surface. Click hide. Okay, this is my side view. Okay, I believe you know this is nozzle. This is the base of the fountain, and this is water, right? Okay.
Okay.
Can you see this is the time? This is 60.05 second. 60 second took 1200 cycle to complete. Okay, so go to the plane and then go to the contour. I want to display what you want to display. For example, you want to display the temperature. Click temperature and
Mm-hmm.
then scroll down. Can you see?
Yes.
Yes. So the temperature, okay, this is my setting before. Basically, I set the temperature of the room is 42.
Yeah.
Okay, okay. Because of the water, you can see because of the water evaporation, it cool down the near region here. You can see
Okay.
here. So the temperature close to the water is 31. Before it is 42. So this is the effect of evaporation. Okay. This is the effect of evaporation. Okay, for example, I want to capture my video, what happened at 0 second until 60 second. Okay,
Yeah.
what I can do, go back to my file, double click my file. You can see we have the cycle.
Yeah.
Okay, go to the first cycle, which is 0, double click. You can see the difference here.
Okay.
Okay, this is nothing. The water not started yet. The operation. Okay, this is the initial stage. You can see the temperature surround the room is 42. Okay, and
Yeah.
then I need to capture the video of the temperature change due to the evaporation.
Mm-hmm.
Check W and V as the video, and where you want to save your video. For example, I want to save my video in temperature of air. Confirm it. Yes. And start recording. Go to your file. Go to the cycle. Check the automatic selection and run it animation. Okay. This is, can you see the water start to?
Yes.
Uh, is activated. Okay. That is water droplet. Because of evaporation, you can see the flow of temperature, the cooling effect.
Okay.
Okay, this is just a simple default value. If you want to change the parameter to have more diffusion, also can be done.
Okay.
Okay, the water generation produced at every 2 cycle interval. Every 2 cycle, it will produce the water generation, water spray.
Yes.
Okay, this is time 27 second, 28 second. This is every 1 second. Okay.
Okay.
Okay, at the same time, let's take a look our simulation. Okay, this is our simulation. The current time now is 14 seconds. Okay. Later
Mm.
on, we will try to view this result.
Okay.
Okay. Okay, this is 40
So,
seconds.
yeah. Okay, doctor. Can you just let me know where's your what's your website, because I will try to repeat what you did in my model. Okay.
Mm-hmm. Mm-hmm.
And inshallah, in the future, I will ask also for extra training for the kinetic facade.
Oh, okay. May I know what's actually I tried to Google. The kinetic facade is actually is the program to control the plane.
Yes, yes. Usually we do this in the software. The name, the one we use is Grasshopper. You know,
I see.
you know it. You know
Okay,
about Grasshopper.
uh, I'm not sure, but
I will send you. Yeah,
okay. So normally you can do using the grasshopper.
yeah. Usually we use the Grasshopper, but the issue now, if this software they can do it, so I can just concentrate in one. So this better for me.
Oh, yeah, yeah. Yes, you can do the motion of the plane at the different time interval. Okay, now it is complete 60 seconds. So I want to see the result. Okay,
Okay.
okay.
Love
This
that.
is this is the temperature of air. Okay, can you
Mm.
see?
Yeah. Oh, okay.
All right. Okay. So if you want to look at the humidity, okay, go to the plane, change into the um, relative humidity. You can see.
Oh,
Okay.
okay.
Okay. So now the simulation. Okay. Right. So this is the previous one. We set the simulation indoor temperature or ambient temperature to be 42. Okay, let's take a look our new simulation. We set the temperature to be 30, 32 or
Five.
35.
Mm-hmm.
Okay, just close this one. Go to the new simulation. Can you see here? We have at 320 cycle.
41. Mm.
Okay, let's take a look what happened to this simulation.
Okay.
Okay, okay, just drag and drop the last file into the
Mhm.
post processor. Okay, can you see?
Yeah.
Okay, do you know why the water out from the fountain? Because we set the velocity before. It is
15.
15 meter per second.
Yeah.
The previous simulation we set as the 8 meter per second. You can see the
Okay.
result. Uh,
Mm-hmm.
okay, let's see the difference in the velocity of the nozzle. Okay, adjust the position. Okay, this is my water drop generation. Go to my particle and change the color to be blue color,
Mm-hmm.
and then untick untick the point and scale it to be 0.3, scale down, and then
Yeah.
draw it. Wait for a while. Okay, can you see?
Yeah.
Yes. Okay, this is your water. Alright, and next I want to unhide. I want to hide my surface. Click surface. Okay, this is my surface. Sorry, yeah. Okay, so can you see my plane?
Yeah.
Do I need to adjust the orientation of my plane?
No.
Because my plane is positioned horizontal. I want
Yeah.
my plane to position vertical. So how to adjust my plane orientation? Go to the x axis. Okay, can you see this is the x? I want perpendicular. I want my plane perpendicular to the x axis and draw it. Can you see?
Yeah.
Okay, and adjust A. Press A button on your keyboard. Okay, this is good.
Okay. Mhm.
Okay, and next I want to see my contour plot of the temperature. Okay, this is at 70 cycle, 70 second. So go to the contour plot, display the temperature and draw it.
Oh
Okay,
yeah. Mm-hmm.
okay, okay. Okay, this is the relative humidity. Okay. Okay, let's see at the different, let's see the temperature. Okay, so let's start our cycle at 0. Cycle, okay. And then start the recording. Go to the camera and then go to WNV, our file format for the video. Browse it where you want to save. Temperature of air at 15 meter per second of the velocity. Confirm it. Okay, meter per second. And confirm it. All right. So go to start. You need to start the recording. Click start, and then go to the cycle. Select the first cycle. Go to the automation and start the animation. Can you see?
Yeah.
Okay. Okay, now finish the simulation. Go to the camera again and your simulation.
Mm-hmm.
Actually, you can see the flow nicely lah. You can see the water fountain flow of water.
Yeah.
Maybe you can have this velocity. You increase more the wall coverage.
Okay.
Okay. Okay. Basically, what do you want to ask me pertaining to the CFD?
Mm-hmm.
Okay, let's check the file. If you want to adjust, for example, um, have you done the building? You said before you want to edit a little bit of your
Yes.
building, right?
Not yet. Maybe today I will work on this one. Inshallah.
Okay. I want to show you basically what you want to edit. You want to scale up, or you want to scale down, or you want to
No,
have other.
I want to remove the something the furniture outside and inside. Okay.
Hmm.
To just put the walls and window and door.
I see.
This one it
Okay.
will require another class later. So inshallah, I think we reached the end of this course now for the three lesson.
So
Okay.
okay.
Mm.
Okay, so I think that's all for our lesson. I show you. Remember, the first lesson is the fundamental of
Yeah.
CFD. You learn about the
Concept.
mesh, the concept,
Mm.
how what is the computational domain, why we require the computational domain, how to size the computational domain, and we do the mesh creation in order to solve the numerical calculation at every of your mesh. So
Yes.
after that, we do the geometry creation, and we assign the boundary condition as well as do the meshing. So
Material.
with
Mhm.
the two file, the solver as well as the mesh, we import into the solver to execute the calculation. After
Yeah.
execute the calculation, we can monitor the maximum temperature, minimum temperature, the flow rate, all of the property. So we can visualize the result. So
Yes.
actually, my advice, we can for your case, as I mentioned before, you can import your geometry, and then you are not necessary to follow to do the mesh to create the model inside the software, because I believe for the beginner like you, it is harder to create the
Model.
model by using the
Okay.
software. So you can create using other software. Just import it in the assist stream. So if
Okay.
you do not know the boundary condition, what you can do, you go here, you go to the assist stream,
Yes.
you launch the assist stream, go to the open user guide, and go to the exercise.
Yeah.
Okay, okay. So, for example, your case involve of the um, solar radiation. You go to the solar radiation, you can see. Okay, this is my case. Just use the parameter here. Okay,
Okay.
you start from assign the boundary condition. Remember, we set the condition wizard analysis control. I want to select the incompressible, select the lamina. So if you want to learn the water droplet, go to the particle tracking and go to the here analysis of to consider droplet. Can you see the droplet
Yeah.
and latent heat of evaporation? So I
Mm-hmm.
want to make sure my result. You can see my result. Okay, this is my result. Okay, exactly the one that I want to create. So you can use this example as your boundary condition. This is just a shortcut. Okay.
Okay.
You, uh, I think that's all you can fully utilize. If you have
Mm.
any issue with the software, please let me know. All right. All right.
Yeah. Sure. Sure. Okay, Doctor, what is your website so I can download the video and to repeat it?
Uh,
And this one thing, and inshallah next week, inshallah, can we make another course for the how to model dynamic subject? I believe
okay.
this one it can do it.
But then can you repeat that?
I mean, if I want to propose a strategy like a kinetic facade because I have to make balance with the light intensity inside. So the kinetic
Oh,
facade is something, yeah. So can we ask? Can I ask for extra three classes, inshallah, next week maybe, or when the time when you are free? maybe after 2 weeks, after 1 week.
Okay. After
So I
maybe
can
next.
send you also email request for workshop for specific subjects.
Okay, so when you
Okay.
request that, I try to create first your issue, and then I try during once I successfully solve your issue, I can show you during the workshop. Okay,
Okay. Okay.
okay, this is my website. Can you see?
Well,
Okay, this is the workshop I did for University Tun Hussein on Malaysia in local. For your
yeah.
case, I will create one page CFD workshop for Hamsah, and then I will give you the link. So this is just example. Actually,
Okay.
basically this is 3 day workshop. I give them the training.
Yes. Yeah. Okay.
Okay. I think that's all. Okay. Please let me know anything if you want
Inshallah.
to.
Thank you, doctor. Thank you so much. And inshallah, for sure, they will communicate with you after I finish. I will convince them with my result. Then they will communicate to you. My
Okay. Okay. Sure.
university. Okay. Inshallah.
Okay.
Thank you so much.
Okay.
Thank you.
Okay.
Okay. Take
Okay.
care. Bye bye.
Welcome. Okay. Assalamualaikum.
Alaikum salam.